Cool.
So
Right
you
on.
you were, let me just double check. Yes, I think we're live. We're back. So first of all, sorry about that. Some technical issues on my side. Should be fine from now on. You were saying that in college you started doing a lot of lower level stuff, or what we would call lower level stuff in C. Any other particular languages that like was that the language you started programming with?
Yeah, so C was my first language. And I did C for a really long time. Like I did C professionally for a while. And and then eventually just realized that wasn't what I wanted to do in my career. I wanted to like just go try other stuff. So I taught myself Java, taught myself Python,
Hmm.
and then eventually taught myself Ruby, and did a whole smattering of other jobs. Did some like kind of like old school giant Java SOAP services and stuff like that, and then eventually like made my way into Ruby. Did some like Ruby and Rails. I never really was like a Rubyist, as a lot of people coming to Elixir like kind of claim like a Ruby background, and I really don't. I did it like it was purely utilitarian for me. Like I needed a job, and this was more interesting than all the Java work that I was doing. So, and they were doing Ruby and Rails, so it's
That
like
was
it
a
could have
web.
been whatever.
What kind of job
Hmm.
was it? Just wondering. Is a web was doing Rails, so not just Ruby, but Ruby on Rails.
Yeah, yeah, mostly doing Rails,
And
and just like silly web
you
apps and
didn't
stuff like
enjoy it
that.
at the time, but
No, I mean, I don't know that I didn't enjoy it. It's just that I never really, um, I think for a lot of people, Ruby was a revelation to them
mhm.
in the sense of like what programming could be, what building apps could be. And, Rails is sort of famous for its ability to build stuff really quickly. And I think that was like a revelatory thing. And whether or not that's good or bad, I'm not here to say, but I think it's true that that had a massive effect on the landscape of web developers today. And so, you know, I, it wasn't as much of a revelation for me. It was like cool. I wasn't like so enthralled by it that I like got
Mhm.
really really into Ruby. Um, I never really fell in love with it. It was a cool tool. I liked it, but at the same time, I was sort of like I'm way more interested by the problems that I was solving at the time. And then eventually, like, got bored with those two because it's just a lot of like web apps and stuff like
Yeah.
that. But
So then the transition was from Ruby in that like web um, job to Elixir. That was the transition.
mhm.
Uh,
Yeah, so I picked up Elixir. I don't even remember when, zero dot something, and like I learned about it because of like I was in this that Ruby space, and obviously like Jose,
mhm.
I mean we all we're the same reason we all got here,
Yeah.
right? Or a lot of us got here
Yeah.
from Ruby, uh, but I was interested in doing other kinds of work. I wanted to get back towards just like kind of like not lower level, but sort of like more service infrastructure stuff. I
Yeah.
wanted to stop doing front end stuff, and yeah, Elixir was a great fit for that. And that was also just intriguing. Like I hadn't done work with Erlang before. I'd heard about Erlang, but I'd never really dove into it. And I think for me, like Erlang was the revelation for me that a lot of other people have had in other runtimes, where it was all of a sudden like this whole class of problems that I'd had in a lot of the rest of my career. There was just all these tools and ways to like talk about solving them and talk about building things that were fault tolerant, and that was like fascinating to me. I fell in love with the runtime almost immediately, just because it solved like I instantly the pathways in my brain instantly saw like how it could be used to solve all these
Yeah.
problems that I had had before.
Did you have do you have a hard time at the, back in that time to find a job? I mean, like even today there aren't that many Elixir jobs.
Yeah, so I mean, at the time, there definitely weren't that many Elixir jobs, or weren't any really Elixir jobs. I pitched it, and continued to pitch it for a couple of years at the company I was at the time, as like a hey, I really think we should care about this. This is really cool, and I think it's gonna be important. Um, But yeah, I mean, I didn't really even think that I could get a job doing Elixir at the time. Like, it just didn't feel like a real thing.
Hmm.
But I just was compelled by it and I was really into it. So I just kept up with the community and worked on open source stuff and started contributing right around the time that Elixir went like 1.0 is kind of when I decided to like commit to contributing my own stuff and trying to get more involved in the community, doing talks and that sort of stuff. Um, and just kind of kept with it for a long time until I eventually did find my first Elixir gig after that.
So that contributing to the community, I know you have a few open source projects of your own, but what was that first one? Was it Wallaby or something before
Mhm.
that?
No, yeah, it was Wallaby. Wallaby was the first thing that I really started working on. It was me and one other dude I worked with. We wanted that tool. Well, essentially, we wanted to eliminate all of the reasons that people were telling us that we wouldn't use Elixir for projects. And because we both like were really into the language and really wanted to use it, but every time you presented it to the rest of like the company, there was all these questions about how does it do this, how does it do this, how would we replace these things, and one of them was like, because we were mostly a rail shop, they were like, well,
Capybara.
how would we, yeah, how replace Capybara, and I was like, we'll just build it. And at the time, it was right when Ecto, I guess it was Ecto 2. I don't remember the versions anymore, but Ecto had just released the sandbox stuff where you could do concurrent testing with it.
Hmm.
Um, and we were like, that would be killer if we could like use that as part of our test suite, as part of these browser tests, right? Um, and so yeah, we just sort of like hard committed to try it. We like I think we built the first prototype of it in like a couple days. I happened to be in San Francisco working with him at the time, so we just kind of slammed out a quick prototype, and yeah, that was it.
And do you remember what was the first actual production Elixir code that you wrote? Was it still for that company, or you were never able to sell that Elixir on the company?
We eventually rewrote an internal tool that company had. So I guess technically speaking, it's like the first. It's it's not really the first interesting thing because at the end, like it's like used by like five people, so it's like that doesn't really count. Um, but so that was the first like foray into it. But after that, my first like real production work was at a company called Latote,
Hmm.
um, and a whole bunch of us all, like a whole bunch of Elixir people, all went to that company all at once,
Yeah, I remember
and that
a
was
few people from the Elixir community being there. Is it still true? Are they still doing a lot of Elixir?
they still have Elixir. They don't, the business model's kind of changed a little bit,
Hmm.
and they don't. A lot of those devs aren't there anymore.
Sure.
Um, but yeah, they still do a lot of Elixir. A lot of it's pretty stable now, and they're doing like I said, the business model has just
Yeah.
changed, so we're just not all there anymore. But
When you got there
um,
was a lot of interesting Elixir stuff to do, is what we were saying.
yeah, so there was a ton of interesting stuff going on at the time. We were doing a ton of nerves work, and we had a couple different like Phoenix applications, a couple different things going on all at once, and we were doing a lot of like. I mean, I would say like it was most of the work we were doing. It was in a factory and trying to get like telemetry data
Mm.
out of a factory, essentially, or out of a warehouse, and build like user experiences around that, and like do warehouse management and inventory management and stuff like that. And so a lot of those kinds of things we were building like custom hardware devices for,
Mm.
using nerves, and then having those talk to different servers in the warehouse that could then like sync stuff back up to like a central server. So there's a lot of interesting stuff going on, um,
Yeah, so you're
for
saying
sure. It was
you
fun.
used a lot of nerves from what you're saying, but other than that specific hardware thing, would you say that Elixir did you guys a favor, let's say, in that project? Why Elixir over something else? Like, do you think like it sped up
Um,
any of the development process or?
yeah, I think so. I mean, well, I mean, we should never. underestimate the power of a group of people who just really like a thing.
Right.
Like, you know what I mean? So like that's a real thing. I'm very firmly of the belief that you should always pick tools that your team actually likes to use.
Yeah.
So that's a big part of it, is like we just all loved Elixir, and so we were
So that
very
helped. Yeah.
maximally productive in it because we knew everything about the language. You didn't have to teach anybody who came into that company because we all just knew the language already, and had like ways of working. We all had real strong opinions, and sometimes that, had interesting arguments about stuff. But it was good. It was fun. I think there were some technical benefits, mostly because we really valued Elixir, and all of the process infrastructure allowed us to model certain interactions in really clean ways, and do really, really fast updating
Hmm.
for certain types of inventory. So as inventory was moving around in the warehouse, you could actually kind of keep track of it, figure out exactly where it was, because essentially like each thing was a process. And so we could actually track each individual item like moving around. It was isolated, it was fault tolerant, and it allowed us to do really quick updates everywhere, and get that kind of information back out to end users and have it all interact with all these different user experiences. And yeah, it provided a bunch of affordances
Hmm.
that were really nice. We had big plans to do all kinds of other stuff, like we didn't ever really get time to do. But at the end, like the technology definitely helped us solve those problems. Um, but it also was the technology that we loved,
Yeah.
and
That
so
always
we
helps.
were able just to use it. Yeah.
And from Thought you went to, was it FanDuel? Am I mistaken? No.
I'm at Bleacher Report
So
now.
you went directly to Bleacher Report? Oh,
Yep.
I had some mistaken then there.
It's so
And
good.
but Bleacher Report, I believe, I don't know if you were there already, but there was a big transition to Elixir, right? Like they wrote an
Yeah.
article that made the rounds at the time. Were you there already? Were you part of that transition, or you came afterwards?
Yeah. So I came in after a lot of that initial work had been done.
Hmm.
The reality is like there is still Ruby at, Bleacher Report that we're still like trying to replace. It's less and less critical these days,
Yep.
and at this point, it's basically all fairly non-critical. All the important stuff's been moved, but there's always going to be those like last little bits.
Yeah, I
Um,
was asking because I'm interested, being I don't know if everyone listening knows like what Report does, and maybe even I don't know everything Bleacher Report does. I'm sure, but the distributing of information to a lot of people, I'm sure there's a lot of, as you were saying, fault tolerance, distribution concerns to have into account. And I was really interested. I don't know if you can share this, like how the architecture of such a thing works, particularly in Elixir, which is something that I.
yeah, for sure. So as we use it, we get a benefit out of it in a bunch of ways. Definitely for the biggest win, I think, is, well, not the biggest. One of the biggest is the distribution of like alerts and those sorts of things. So when a big breaking news event happens, um, we have a pretty robust pipeline for how that gets out to potentially millions of people.
Is that anything
And
that's out of the box Elixir, or is all custom?
Some of it is. We're using a lot of the. I mean, the great thing is you have this toolbox, right?
Right.
You have all the things that you need to build these kinds of systems in Erlang. The downside to Erlang is you got to put it all together, but you do have it all, right? So you have to take this kit of parts and kind of put it all and assemble it. But that's fine. These days, it also relies pretty heavily on GenStage, because that's a thing that we take a lot of advantage of, for that specific use case, because it just helps us batch all that stuff up and get it out as fast as possible. So but a lot of that stuff, I mean, we're using a lot of the same we're using a lot of the same Erlang stuff that you'd expect, right? It's ets tables, it's gen servers, uh, and and then just doing a lot of like analysis to figure out where your bottlenecks are
Mm-hmm.
and try to keep like removing those. So specifically around distribution, it's like this giant gen stage pipeline that's like pretty tuned at this point and is mostly working out of like memory or trying to work out of memory. Um, so that's 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 our common solution for that kind of stuff. I want to call. Go.
So you're saying
In
you guys use a lot of Gen Stage, which I personally haven't used a lot, but I know there's now something related to that called Broadway, right? That just recently came out. Is that interesting?
mm-hmm.
Something that you would consider replacing the Gen Stage you have with,
uh
or?
no, probably not. I mean, just because I mean, to be honest, like I just like things that are boring, and at this point, like our stuff that works is pretty boring. Um, and so we don't have any at this point where that pipeline specifically is pretty tuned,
Yep.
and I don't think
Just
there'd be a
don't
ton of
mess with
benefit
it.
in like rewriting it. Yeah, like there's always other stuff we could tune, but at this point, it's sort of like, how much money do you want to throw at a problem to get slightly better, efficiency? And because like it's pretty robust already. We just had the NFL draft,
Mm-hmm.
which is a pretty big traffic day for us, and our notifications were getting there to people's phones before the actual announcements were being made on TV.
That's fast.
So like it's pretty much like as tuned as it's going to get. There are certainly places where we could consider using Broadway. There are other use cases elsewhere in the system. We haven't really looked into it too much right now.
Mm-hmm.
Broadway is definitely really interesting. But the places we would use it are all around. We do a lot with Kafka
Mm-hmm.
behind the scenes, and right now, the Broadway stuff isn't quite at a place where it would make sense for us to do that in terms of its Kafka support.
Right.
I've actually talked to Jose about this a bit, and like I keep saying that one day I'm going to go and actually help work on the Kafka adapter for Broadway, but it's just really far down the stack, so I haven't gotten around to it. But yeah, right now it doesn't quite suit our use
Okay.
case. We already have kind of like custom tooling around it, but it's definitely an interesting project.
In terms of the processes and managing processes, uh, how do you handle that across the, I don't know if it's a distributed beam, if it's just one, or how does that work? Particularly, I'm interested in knowing, like, do you use the out of the box registry or you use something else, or you don't use a registry at all?
For certain use cases, well, okay, so we only have a handful of apps that actually use distribution.
Hmm.
Um,
Distribution as in
that's
distributed beam?
Yeah,
Okay.
yeah, exactly. Yeah, distributed Erlang.
Hmm.
Yeah, there's only about a handful of apps that really of services that use it behind the scenes, and it's for very specific reasons. Most of our other services are just like web services. Well, I say web services. They're like,
Serving an
they're
API or
services.
something.
Uh,
Yeah.
yeah, they have an API. They're an API, right? Not all of them. Pretty much none of the rest of them are using distributed Erlang for anything. Um, so in those apps, if we need like a pool of gen service or something, or if we're going to do some like caching, right? Um, a lot of our use cases for it, you can get away with like pretty simple, straightforward stuff. It's like ets caches that you fall back to when downstream things are degraded or can't serve live traffic anymore. Um, and for those scenarios too, if we need gen servers, then we would just use registry. Because registry is really good. It's really fast. It shards ets tables to avoid contention and all that stuff. It's really good. You should use it. For the distributed stuff, we there are a few places where we have custom registries.
Hmm.
And the reason for that is because we need to find a process on a box. And we know it lives on, we don't know the PID, we do know it lives on that node. It's like we know the node it's on,
Mm-hmm.
but we don't know the PID. So we use the registry on that node to get to look to do the lookups and stuff like that. And so we have like a small custom registry implementation for that. And that also relies on consistent hashing. So we know the nodes that are in the cluster for that instance or for that service. And then we can just sort of say like, okay, this address is going to like this ID maps to that node.
Mm-hmm.
Go out, ask that registry where it is, get the PIN, and then you can talk to it.
Got it. Okay, it makes sense. So in talking about processes, I read in your blog recently, I think it's semi-recently, you have an article about the single global process.
Yeah.
And I was wondering if you want to talk a little bit about that and what are your takes on how to handle that situation?
Sure. Yeah. So the main thrust of it is a lot of people coming to Elixir. The thing that I fell in love with, right, and I think it's the thing that a lot of people fall in love with, is the process. You're like, these are amazing. Like, I have these processes, they're fault tolerant. Like, if they crash, we'll just restart them. This is beautiful, right? You get supervisors, you get gen servers, you get all this cool stuff to start playing around with. And then you go to build your first, Phoenix app or whatever, and you realize that like you don't get to do any of that stuff anymore because the Phoenix app like did it all for you. Like it solved all those problems for you, right? And I think my intuition is that where that leads people is they want to use those things. It feels like you should use those things. And where they end up using them is their like domain logic. They're like, I'm going to have a process for my entities because then I can keep data in this process and I can like event source it or something, right? Like I can, or, whatever, like I can send messages to it.
Mm-hmm.
It'll keep this view of the world. Eventually that view of the world gets like dumped into a database somehow. And if it crashes, it reads it back out of the database and starts over. And anybody who wants to talk to this item or this thing talks to the process, right? And that feels really good. That feels like fun because you're like, it's coming out of memory. It's fast. Like,
I mean, do you think that also comes from people coming from OO and trying to replicate what objects and data encapsulation feels like in a process?
I think so. Well, and it is tricky too because you have so much of what we love about Elixir 2 is this data manipulation thing, right? Like I have these pipes, I have enum, I have streams, like I have these ways to talk about data and manipulating data. I have a mostly good library of like pretty robust data structures, with the exception of lists, which are garbage. Like as far as data structures go, this is like my personal. I talk about this a lot. Like I hate lists. I think they're a bad data structure, but whatever. That's a side rant. But anyway, so like you have these data structures, you can manipulate them. But then once you've done all that fun data manipulation stuff, like where do you put the data? If you're in the request response loop, it all gets mucked up. Like all that pure data manipulation stuff gets intertangled with all the like garbage of the web request and the query you need to make with Ecto, and it's all very imperative and like it takes you out of that world. And so I think it's a combination of all those things. Like people want encapsulation, they like doing this data stuff, and they like having a place to put it. And it feels good. Like it feels right. You have a process. It's in this tree. It's going to get supervised, and you can do this like state management cycle, and all that feels really, really nice. The problem with it is that it totally falls apart if you need to run on more than one box. Because if you need to run on two machines, those machines aren't connected through distributed Erlang, yep. Then you spawn two things and now your data is out of sync. And if you're writing to the process and the process is dumping it into a database, and it's doing it on either side, you have a really high likelihood that you're going to overwrite data or trample stuff or whatever. And there are certainly ways around that, but it's, you open yourself up to this very complicated set of problems that you need to solve if you adopt that from the beginning.
Mm-hmm.
And so that's really what the blog post is about, is one, trying to convince you that this is a problem you should care about at all, and explain some of the problems, and two, try to provide a language to talk about, like, what, how would we actually go about solving this? How can you solve this generically? Because here's the litany of problems you'll have if you choose to do this, and so you need to be prepared to solve them. Like,
So
you can't just do
your
this.
solution or set of solutions are what, you either have a single global process as the name of the article, or is it just like, just don't create processes for your domain logic, especially I'm assuming in simple or medium complexity web apps using Phoenix, because most of the distribution fault tolerance is already there. You don't need to worry about it.
Yeah, I mean, that's the takeaway. One is just like, man, just build a normal old API.
Right.
That's boring, but you can go a really long way if you just build a really boring API. You actually don't need any of the fancy stuff. And by fancy stuff, I mean, like, you don't need some event source process thing. You don't need, a lot of tools. You don't need all this other stuff. You don't need distribution. Like, you can just build a web API and it'll be really fast and really robust. And, you can actually service tons of traffic. Like, that's BR's, like, strategy up until recently, is just build dumb APIs, and that'll actually take you a really long way. And it actually really does. We're at a point now where we have to really revisit that, because we're attempting to because of two reasons. One, we're attempting to solve much harder problems than we were before, and two, we're at a high enough scale where you really have to start, like, where you can't just do a dumb API anymore. Or doing a dumb API doesn't, you have to scale out horizontally
Mm-hmm.
so far that you're spending a lot more money now, and all these kinds of things.
Yeah, but I guess
Um,
when you get at that point of scale, at least, hopefully, if your business model is good enough, you'll have also enough money to think about it more thoroughly,
right.
so that's good. So something that piqued my interest that you were talking about, while you were talking, you were saying the list side rant.
Yeah.
Why I know, like, so Elixir implementation of list is basically a linked list with very little
Mhm.
else on top of that. But why do you think there's just inherently a bad data structure?
So I think I mean, cons lists are like they're venerable, like, they're really, really old, right? Like, Lisp had this way, way, way back in the day, right? And they're like sort of the original, like, immutable data structure.
Mm-hmm.
The problem with it now is that there are better ways to represent, I mean, okay, so, like, what is a list trying to achieve, right? A list is just a big sequence of things.
Mm-hmm.
Um, uh, and you want something that represents a sequence of things. That's a really useful primitive to have. The problem with linked lists and with cons, like, lists like we use, is that they're expensive to get stuff at the end, right? It's really quick to get stuff at the beginning. It's really quick to put stuff and get stuff out off the front of the list. But if you want to go to the back of the list or have arbitrary indexes into the list, those are really, really expensive operations. If you want to concatenate lists together, that's a really expensive operation, right? If you want to, like, split lists arbitrarily and rejoin them, these are all, like, expensive operations that are and so they're just a really weak data structure, because they don't really give you any power outside of, you can put something at the front of it and get something off like really quickly. That's, like, not a useful
They're
enough
good for
thing.
recursion, basically. It's
Yeah, and they're also good when you have limited memory and you have limited CPU power, and, like,
right.
when basically, if they were really good when you were 30 years ago. Like, if you lived 30 years ago, they were great. Like
So
they were what you had.
what's your alternative? If in Elixir, like within what you have, is there anything that you use like to represent a sequence instead of a list?
So it's really complicated in Elixir because I actually think, unfortunately, Elixir is actually making the right choice to use lists, um, because we have to be able to interop with Erlang, and Erlang uses lists for everything, right? Like, so we're paying for the sins of Erlang here, which is not really. I mean, it's unfair to level this against them given how the age of the runtime and
Yeah, it started
everything.
like 40 years ago,
Um,
so they were ahead of
yeah,
their times.
exactly, right. So it's it's not fair at all. But unfortunately, like the cutting edge of those data structures is, has moved on. So if what you want is a sequence of things, um, there are ways to build immutable vectors, um, now that have much better capabilities, and they represent just as well a sequence of things, right?
Hmm.
But there's the sort. I think I haven't kept up with it too much. As far as I know, the best is known as a RRB, a relaxed radix B tree, um, and essentially you can model like a list of stuff, a vector, as a tree.
Hmm.
And so you get very good access time. So getting something at the front or the end is constant time, and doing any sort of arbitrary indexing is O log 32. Um, and so that's pretty close to constant time, depending on how big that thing is.
Hmm.
And but like splitting and concatenations all also O log 32. Um,
So,
they just have way
but
better
that's
power, so you can
something
do more with them.
you would reach out generally, while working on an Elixir project, or just like if you're anticipating having big lists, or what's the rationale?
Yeah, I think if you know you want to deal with like giant lists of stuff and you want all this other power, like to be able to just arbitrarily access information, there are persistent vectors implementations in Erlang and Elixir that you can use today,
Hmm.
and you should totally use them. The downside to those is the same reason that is the same downside that like map set has, which is a super useful thing when you need it, because you need sets a lot in my experience. Uh, the downside to it is that it's this other abstraction thing. It's a struct, right? And you can't pattern match on it. You can't, the operations that are built into the language, the most ergonomic operations that are built into the language are built around lists. And so you're using a less ergonomic abstraction
Got it.
around all that stuff, because all that stuff is built around lists, like pattern matching and all that.
Makes sense.
So it's just sort of a bummer, like, because we could improve that, but you'd have to improve it at like such a low level, and I don't, and it would break tons of backwards compatibility stuff, and like you're never going to do it. It's never going to
Yeah, I
happen.
think
But
backwards compatibility has always been a big thing for Elixir. I think so.
yeah,
It's hard to change that.
yeah.
Another.
So like,
Yeah, go ahead.
you just use the struct version. You just use the struct version, and you're fine if you need that. The downside is it does limit the way you think about building algorithms, right? Like it affects the way that, because we know lists are limited, because we know a list can't handle 10,000 things in it. Like if you need arbitrary access and you have 10,000 things in the list, you're just screwed. And so you just build your problem such that you don't have that. You just pretend like that's not a thing that you can do,
Hmm.
and it completely changes the way you think about algorithm design because it's not accessible to you. Um, and that's the real bummer, is to think about a world where you didn't have that limitation. Like, what would that be like? And you could, we could live in that world, but it would also mean all these other trade-offs. So like, that's why I say like Elixir's right to use lists. Um,
I think the
doesn't mean that they're good.
okay. No, I get your points. I think like stream lazy evaluation is kind of trying to combat that a little bit. In As
Hmm.
you were saying, like we pretend we don't have big lists, just go one at a time, one element at a time.
Right. Yeah.
Um,
Yeah, for sure. And streams are really useful for that stuff. But I think, again, like the downside is that they're they really only let you talk about, um, iterations over sequences
Yeah.
of stuff, which is very useful on its own. And I love stream.
Yeah,
I mean,
but
stream and enum are
random
some of my
access
favorite
is still
things.
hard, right? So that's
Yeah.
always
Well, and the splitting and
yeah.
joining and concatenating that part gets tricky too. So
Another thing, so going away from lists for a bit, another thing that at least for me you're famous for is your rants on config on both mixed config and generic configs in Elixir. So I had two questions for you. So first of all, why do you think you became famous for that rant? And secondly, what is as of now for you like the best way to handle configuration in let's say a Phoenix app?
yeah, sure. I don't know why. I guess it's just because I said it loud, like very
Mhm.
loudly and unapologetically. Um, I guess that's why I get associated with it at this point. Um, but you know, my opinion on how to deal with it now is actually really straightforward, which is that for anything that requires runtime config at all, unless you're totally handcuffed by a library that you're using, just avoid config.exs. Just don't have it. Like if you can just not have it,
Mhm.
you're in like really good shape. Start with that as your premise of like we're just not going to have config.exs in our repo, right? See where that gets you, and actually because actually you can go really far with that.
But
Um,
do you mean by not having configs or by moving configs to your like init callback? Is that what?
Right. Yeah. So the way we do it these days is we use a library called Vapor that I wrote. I mean, I wrote it forever ago, and it's gone through a bunch of iterations. But I think I like where the structure of it is these days. It still needs a good like a good user friendly API around it. Um, the way it works is you essentially create a tree of stuff that you want, and it knows how to go and like satisfy that tree
Okay.
and group it all together and join it and merge it. And what it gives you back is a map. And again, you get a map that has all the config values in it. The other really important thing that Vapor does, so you can go into Vapor and you can say, I need to get these environment variables. They map to these actual atom keys, and while you're doing that, if you find it, run it through this transform. So string dot to integer or whatever arbitrary function you want to do. And a really important uh, not constraint, a really important design principle for Vapor is that if any of those things don't exist, it should raise an exception or it should return an error, depending on there's two functions. There's load and there's load bang. Load bang returns an exception. Load
Yep.
returns an okay or an error. Because it's really important that you halt the boot process if any of those things aren't there. That's like a really, really critical thing. We've had so many bugs in our apps where certain config values are like, defaulted to something or, default to something for dev or whatever. And then they're not there in production or they get misspelled in production. Or just like there's a problem with
Hmm.
production, didn't load it correctly from parameter store or whatever. And now like the app is booted, but it's wrong and it's erroring and it can't tell you why. And you don't know why. And it's going to take you a second to go figure it out. Like you just want to avoid that completely and just like stop the boot process. Like don't allow the app to boot. At all
Hmm.
in bad state. Otherwise, like you're just inviting more problems. So that's the other big thing that Vapor does. Um, so the way we orchestrate that is the very first line in application, your application module, your start function. The very first line is vapor.load. Here's all the stuff.
Okay.
Go load it. And so we pass it this giant thing. The giant thing is really nice. The giant tree of all the things that you need.
Hmm.
It's actually really nice because you can see it all.
Yeah.
There's like one place that you go look at it and you're like, there it all is. This is all the things that I need. And it loads it. And if it doesn't load it, if it fails for whatever reason, it's going to raise an exception. It'll halt the entire boot process and we'll know because we can go look at logs. We can figure out why it's not working. And then in order to get that configuration into like our children, all the children processes that we're starting, uh, For most of them, um, we just pass parameters down in the child spec. We just pass like here's your config here or whatever. Ecto and Phoenix in endpoint are the two outliers to that. In which we actually have to use the init callback for those, just because of historical reasons. Like they support those better.
Mm-hmm.
So so that's what we use for those for both of those. But for basically all the other children, most of them you can just pass arguments down as part of their start link, part of their child spec stuff. And so we just pass arguments down through all of them, and let everything start that way. And that's just how we manage it. And we've had way fewer bugs. Like I don't think we've had like config problems like where an app doesn't know what to do anymore since we've like rolled that out.
Do you think Vapor should be part of Elixir or Phoenix?
No, probably not.
Too opinionated?
I, I, if Vapor's a super opinionated thing, I don't. I think they're. Yeah, I don't know. I doubt it belongs in core like that. Like I don't. I'm not a huge. I mean, if we're not going to put a JSON decoder in core, like we definitely don't need to put this in
Right.
core. You know what I mean? Like there's all kinds of stuff. Like at that point, yeah, you're back in this like, well, why don't we just put all the useful things in there?
Yeah.
So I don't think it belongs there. I do hope that other people who are working on libraries, just let me pass you arguments. That's what I'll say to that is like, let me just pass you arguments. Don't make me use config.exs. Don't make me use application env to load your library. There's a whole bunch of reasons you don't want to do that. And just let me pass you arguments. It'll be cool. So, at the end of the day, like all of our apps do have a config.exs file. We do have we typically do have dev tests prod. And those are really for the libraries that do still force us to use application env, or they're for they're for compiler level stuff, or like for development, we want to put this, we're going to use this fake module for calling this service, but for production, we're going to use the real one. And so that's the kind of stuff that we put in config. And I still think that that's a good use case for config, is those sorts of like, I want to swap out this module name or those sorts of things.
Yep.
But runtime stuff just shouldn't be in there at all.
Cool. Another thing, I don't know if you say you guys use Phoenix. I don't know if you had the chance to look into Live View, which seems to be all the rage now in the community. So I was just wanting to get your opinion on Live View, where it's going, and also if you have looked at the Live View dashboard, which is looking pretty cool, and so I wanted to get your opinion on both of those.
Yeah, no, Live View's super cool. We don't use it, I think, anywhere. We've definitely talked about using it for internal tools. We'll probably never replace the existing front end like web view with it, just because there's like a whole team that already does that. We're not going to go back and rewrite it all. There's like very little to be gained by doing that. We've definitely talked about it for internal stuff, and that may happen one day if we ever need to do that. It hasn't come up yet, but it's certainly cool. It's really interesting. I think it's rad that people really like it. Anything that gets people excited about Elixir is cool with me. Like that's exciting to me. It's not, unfortunately, like it doesn't satisfy any sort of need that I have, just because I'm so far removed from front end stuff these days. Like I haven't written a line of HTML in something like, no, that's not true. I had to write a tiny little bit of like Phoenix something to debug an issue the other day, and I totally didn't remember how to do it. Like I didn't even remember how like ER or the EX. Yeah, I was like, how does this? Is it percent sign equals for this? Like I couldn't remember. Like it's been so long since I looked at it, but but it's definitely really cool.
Is there any downside that you can think of? Because you said you're probably not going to adopt it, but basically because you already have a team doing all that stuff. Is there any particular reason why you wouldn't otherwise? Like if you're just starting brand new, like is it just the fact that it uses WebSockets by default, but you can change that on the channel? But is that a problem or not? Not at all.
Um, Requiring a persistent connection in the browser
Hmm.
is always a problem. It's just always going to be a problem. I think there's always a lot of overhead there. Uh, it's always going to be flaky on certain types of devices, on bad Wi-Fi, on bad 3G or 4G. It's just like you're never going to get out of the situation where that's not a problem for people who are like on the edge of the network, right?
Hmm.
Um, but that's true of web requests too. If you're loading, that's true of like, you know, loading some ginormous like React front end or something like that
Hmm.
as well. Like it's true of loading like a whole like massive JavaScript payload, right? Like people who are on the edge are always going to have crap experiences, um, unless you account for that and make your website really accessible to those people. WebSockets are always going to be flaky,
Hmm.
like they just are. Um, because of the nature of what you're doing, right? And like, you already have a distributed system. If you have a browser reading from a web page, you already are reading
Yeah.
from a web server, you have a distributed system already. Adding a WebSocket connection does not make that problem easier. Like it just makes it worse. That's just the reality of the situation. Um, so all that in mind, does that mean I wouldn't choose live view? No, not necessarily. I think live view is still really good. It's really cool. I don't know that I would use it for everything,
Hmm.
but like definitely for internal tools, right? Like I probably just me being me with my sensibilities and having done this for long enough, I like I'm not gonna build like my company's front end, like my company's like landing page in it because I want that to be fast. I want that to be accessible to people, and like
Yeah.
it's just not. There's no use case there. But like internal tools or like really rich app client experiences, like people are already doing this stuff anyway. Like there's no reason to not use Live View for that. Um, and definitely internal tools, like that's a slam dunk,
Hmm.
because it means that you know even people like me who suck at front end work can like get some stuff done,
Yeah.
uh, and that's a huge win. So there are certainly use cases for it, and there are certainly places where I would use it for sure. I really dig it. And like in like the dashboard thing, I just saw this. I'm still catching up
Yeah.
on my news, but I saw this the other day, and I was like, that's really dope. That's a really good use case for that, right? Having this like live dashboard for services. Again, it's probably not a thing. We might use it for our stuff.
I'm
Um,
assuming you already have some sort of a
yeah,
monitoring setup.
Yeah, we have a pretty robust set of monitoring and logging and all that kind of stuff. And we run too many things to like um, for it to be generally useful on, because like when we have problems, it's like on a specific instance. It's not, or like by that point, like the service you're trying to analyze is already dead. So like, it's like not going to be able to load this like web page thing on top of it. Um, but there are certainly places where we could use it and might use it. And those are more like background
Mhm.
workers and stuff like that. There's certainly a place where, and it looks beautiful.
Yeah.
That's the other,
And
like it is
and
gorgeous.
for me, like a use case, for me that I see a lot of people using is if you're running your app on Heroku, for example, and it's just a single app, you can't run Observer
Mhm.
over there, uh, at least not easily that I know of.
Right.
And having that dashboard just accessible like that is super good, and it does look super nice, which helps.
Yeah. And it's super. I mean, they have a ton of functionality in it. I was just seeing that they
Yeah, they
can
keep
they
adding
can
stuff.
do like logs, like they have, because of the new like OTP logger. They can do like um, some amount of like log collection,
Hmm.
or they can add like filtering for logs and stuff like that. That's super hot. Like I think if for us, honestly, probably for the majority of people running Elixir apps in the world, they could probably just use that
Hmm.
and like be good to go. It just so happens that, we need to run like 40 like instances for some of these
Right.
services. And at that point, it like starts to kind of break down because, you need to actually get to the instance that you actually need to analyze and, you know, it's it's harder to do it that way. But it's a super cool project, and it's cool to see like the kind of stuff that Live you can do, right? Where they can have all these charts and stuff and just do it, and like they're able to render it. It's all like really clean looking. It's all just Elixir code.
Yep.
That's pretty cool.
Cool. So Chris, we're right about hitting the hour mark. Do you have anything else you want to talk about? You want to share? You want to plug something? You do have a
Um,
podcast. You can talk about that.
yeah, so yeah, I have a podcast called Elixir Outlaws. Do that with Anna and Amos. So it's pretty laid back and chill. We sometimes talk about Elixir. We try to talk about Elixir a lot, but it wanders all over the place, and we talk about all kinds of stuff. Um, so it's a pretty fun, just kind of relaxing podcast. Um, yeah, I think I've got some speaking stuff coming up. As much as anybody can do speaking these days, like virtual
Yeah.
conferences and whatever, that'll probably be announced here pretty soon. Um, and yeah, the only other plug I have is I've been recently working on a new HTTP client that we've been really wanting like a pretty high performance HTTP client for use at work, and so we finally just built one. And by I built one, I mean like I slapped together Mint and a library that Jose wrote, and then Nico, the other maintainer for the project, also joined me, and he did all the work. So
And that's
yeah,
that's
it's pretty
already
cool.
out. Is it open source?
Yeah, there's a 0.1. It's on Hex. It's called Finch.
Hmm.
It's on my GitHub as well. And so far, benchmarks are looking really promising. We're adding HTTP2 support. A couple other people have been, like Quinn, have been shipping features in. So big shout outs to them. And they've been keeping that project going while I've been without power. But yeah, so check it out. It's pretty cool. Hoping to get more eyeballs on it.
Cool. Chris, again, thank you so much for taking the time. It was very enjoyable talking to you, and
Yeah, this is great.
let's catch up later.
Yep, sounds good. Thanks for having me.
Bye. Um, so for everyone else still listening, I just want to say that next week, same time, we're going to be here back again with another guest that you'll learn about in a few days. If you subscribe to any of the channels that you can see down here, we'll be tweeting and setting posts on Instagram, pretty much everywhere. Also, Subvisual is hiring a front-end developer. If you go to subvisual.com/blog, you should see a blog post about our exactly what we need. And see you guys next week. Bye.